In today's lecture, we are going to learn new method. We call it variation of parameters, which covers section 4.6 from the textbook. And this method will help me to solve second order non-homogeneous differential equation when the gx, the right-hand side, isn't simple function. So no annihilator for the right-hand side. Let me do some revision about what we studied after exam 1, and don't forget that your exam 2 on next Saturday, and all the lectures which we covered after exam 1 are included in this exam. Okay, now if you remember that we studied how to solve non-homogeneous differential equation with constant coefficients. So if I have this differential equation, y2 primes plus 5y primes minus 6y equal, let me say, x. I can solve this non-homogeneous differential equation with non-constant coefficients. And by the way, the following steps which I'm going to write can solve, or sorry, the following steps which I'm going to write, I should follow them when I need to solve any non-homogeneous differential equation. So here the first step, if you remember, I have to find yc, the solution of the homogeneous differential equation. And to solve the homogeneous differential equation with constant coefficients, I need to use the auxiliary technique. And by finding the value of m's, I have 3 different cases. You have to write those steps on your cheat sheet. When I have the same m, when I have 2 different m's, when I have complex solutions for the auxiliary equation. Second step is to find yb. How to find yb? Maybe by guessing, inspection, or if you have a simple function, so you can use the annihilator technique. Or I will use the reduction of order method by using this substitution, y equal u times y1, y equal u times y1. And what do you mean by y1? It's the solution of the homogeneous equation. Then third step is to write the general solution of the non-homogeneous differential equation as the following: yb plus yc. Always yc is the solution of the homogeneous, the complementary, and yb is the particular solution for the non-homogeneous. Now, if my gx, this function, it is tan, maybe tan x, so no annihilator for it. What should I do? In the previous lecture, we learned the reduction of order method, and don't forget that the reduction of order method, you need to use 2 substitutions. The first one, y equal u times y1, such that y1 is the solution for the homogeneous equation, and y the general solution for the non-homogeneous, and the u is new unknown function which will help me to solve the differential equation. And the second substitution, if you remember, you need to use that u double prime equal w prime to reduce the order of your differential equation. Okay, those ideas we studied in the previous lecture. And don't forget that you have to add to your cheat sheet the 3 rules for the annihilator functions. So here the objective of our lectures. And here, if I have this equation with constant coefficients, notice that this one is constant, and this one is constant, and this one is constant. Now, I have to solve the homogeneous equation to find yc. So yc, the complementary solution of the corresponding homogeneous. Then you have to find the yb, which is a particular solution for the non-homogeneous with this g, So if g is maybe polynomial, exponential function, sine and cosine, or linear combination of their products, you can find the particular solution by finding the annihilator of your right hand side. Okay, then you will add yb to yc. Now we have 2 problems. If you remember, we spoke about them. The first problem, if those coefficients aren't numbers, are not numbers, but those are functions, what should I do? Also, if the right-hand side, this function isn't polynomial, isn't exponential, isn't sine or cosine, what should I do? We learned the reduction of order method, which will help me to solve those two problems. And also we are going to learn a new method, we call it variation of parameters, which will help me to solve the difficulties of those two problems, especially if the right-hand side is a complicated function and no alienator for it. Let me introduce now the variation of parameters method. First of all, when you need to use this variation of parameters, you need your differential equation to be in this form. Notice your right-hand side is fx, and this fx is complicated function and no annihilator for it. And don't forget also, if your function is simple here, you can use the variation. So the variations of parameters is a general method, can solve the differential equation when the annihilator method can do that. But sometimes I have differential equation such the variation of parameters method can solve, but the annihilator no. Now, if I need to solve this differential equation, notice that your coefficients aren't constant, but here the most important thing is that the coefficients of y double prime must be 1. So the variation of parameters method need the coefficients of y double prime to be 1. First step, if you remember, I need to find the complementary solution of the corresponding homogeneous equation. So you need to find the complementary solution of the corresponding or the associated homogeneous differential equation. This one. Now, one students will ask, Professor, how to find the complementary of this? And I have non-constant coefficients, so I can't use the auxiliary technique. Actually, we are going to discuss this problem in the coming steps. Then, to find YB, don't forget, first step to find YC. Second step is to find YB. How to find YB if I need to use this method? And actually, this method, I can use it if the fx, my right-hand side, with no annihilator. The YB, it's a rule you have to add to your cheat sheet. The YB using variation of parameter method is this form. So you have to write this form in your cheat sheet such that y1, this one, let me clean those. This y1 in my yp, it is y1 in my yc. So you found the y1 for solving the yc. And also, the y2 here is a given function here. What about of u1 and u2? Those are unknown functions, not similar to those constants, not similar to yc. In yb, the coefficients of y1 and y2 are unknown functions, and I need to determine their values to find yb. So the aim here, to determine yb, you need to determine the values of y1, u1 and u2, the unknowns functions. Okay, so u1 and u2, here I wrote, undetermined functions, and you have to determine their values. Now I have a small question. If I have two unknowns, those are my unknowns, and I have to find them. How many equations do I need to determine the value of two unknowns?
Two equations.
Two equations. Two equations, yes, you are right. And the variations of parameters need this and need the following two algebraic equations to find the value of the first unknown, y, u1 and u2. So to find u1 and u2, you need to solve those two equations, those two algebraic equations. Professor, you asked me to find u1 and u2 from those two equations, but no u1 and u2 in those two equations. Actually, By solving those two equations, you will find u1 prime and you will find u2 prime. Then integrate u1 prime and u2 prime to get the value of u1 and u2. Don't forget that here u1, y1, this, and y2, those are given functions or known functions from the complementary solution. And what do I mean by prime of y1? It's a derivative. Prime of y2, it's a derivative. So the unknowns in this system are u1 prime and u2 prime. By integrating both of them, you will get u1 and u2. By finding u1 and u2, plug in your particular solution, so you'll find particular solution for the non-homogeneous equation. Notice here, I wrote that the final answer of the non-homogeneous equation star is given by yb plus yc. Yc from the first step, yb from the second step. Okay? Now, in this slide, I'm going to introduce a new method to solve algebraic system. So let us consider the following system: 2x plus 3y equals 7 maybe, and let me call 4x minus 5y equal 11. So I have two algebraic equations with two unknowns, x and y. Can anyone suggest a method to solve this system simultaneously? Any method?
You can add
multiply the first one
So
by 2 and
David,
add.
yes, David suggests to multiply first equation by 2, then subtract it from the second equation. So you will eliminate x. You are right. You will omit x. Islam, what do you need to say?
I was going to say the same thing.
Yeah. Other methods? Can anyone suggest a method? No method? No idea how to solve this system simultaneously?
And substitute y for 11
Yes.
minus 4x over
Yes.
negative 5.
You are right. So from equation number 1, find the value of x by moving 3y and dividing by 2, then plug in equation 2. Great. So you can solve this system easily. You are free. You can use any method. But let me now introduce maybe a new method for those students who didn't study linear algebra. But this method, which we call it grammar method, Grammar's rule or Grammar's method to solve algebraic system. So a new method to solve algebraic system. You can use it or you can use what you need. Okay, let me introduce this method. Notice now your unknowns are u1 prime and u2 prime. Those my unknowns. What about of y1 and y1 prime and y2 and y2 prime? Those given functions, those are unknowns. But the unknowns are those u prime and u prime 1 and 2. Okay? So your aim is to find u prime 1 and u prime 2. But y1 and y2 and their derivatives are given functions. Steps of a Grammar's rule. First step is to find 3 determinants, w, w1, and w2. Let me explain the w. By the way, all of you know the w Wronskian determinants. You will write here your functions, and in the second row, their derivatives. So notice now, my first row here, my first row is the coefficients of my unknowns. So it's y1 and y2. The second row here is the coefficients from the second equation of my unknowns, u prime 1 and u prime 2. So I wrote here y1 and y2 primes. Okay. The w1, it is the same like w, but I'm going to replace the first column by my right-hand side. So take the right-hand side instead of the first column. What about of w2? The w2 is similar to w, but I'm going to omit second column and replace it by your right-hand side. This is the first step. Second step is to write your unknown u1 prime and u2 prime using this rule. So u1 prime, it is w1 over w, and u2 prime is w2 over w. I'm not sure if you studied this method in secondary school, but for who studied linear algebra, they find it's very easy. Third step is to integrate u1 prime and u2 prime. Now, one chocolate for those students who can tell me why the Ronescan determinant can't be zero. This determinant can't be zero. And take care that in your exam, if you find the value of W to be zero, that means you did something wrong. Now, why this W can't be zero at all?
But they are independent.
Because you are right, because y1 and y2, by the way, those y1 and y2, those are the solution of the homogeneous equation. The solutions of the homogeneous equation. Okay? Now, those two solutions for the homogeneous equation must be independent, and we studied that the independent functions must satisfy this condition. The Ronescan determinant can't be zero. Okay? Now, so David, deserve one chocolate. Let me give you the first example. By the way, let us discuss together. Can you find the annihilator for the right-hand side? Can we find the annihilator for the right-hand side? What do you think? The function sec.
No.
No, because the sec, it is what? The sec, it is, yeah? What do you think about the function sec? Do you know the definition of the function sec?
1 over cosine.
1 over cosine. So no annihilator for this function. So if I have similar to this problem in my exam, no need to use annihilator at all. Okay, what I'm going to do. So let us together in the coming slide and write the steps in details. So here the solution, here the solution. Don't forget now that your equation is non-homogeneous. To solve non-homogeneous differential equation, I remember first step is to solve the homogeneous. First step, I'm going to solve y double prime plus y equals 0. Okay. I'm sorry, but I need to choose now some students. Let me choose Ahmed Atif. Yes.
Yes.
So it's homogeneous equation. And notice now your coefficients are constant. How to solve homogeneous differential equation with constant coefficients? What do you think?
M squared plus
Yes,
1
so I'm
equals
going
0.
to use, yes, you are right, the auxiliary technique. So m squared plus 1 equals 0. Continue, Ahmed.
M equals positive or negative I.
Yes, you are right. So I moved number 1, great. So m squared equal negative 1, and that will give me my m equal positive and negative I. Great. Do you remember at that time your y1 and y2?
C1
Yes,
cosine
so the complementary, you are right, C1, great.
sine x
Cosine x, excellent, plus?
plus C2 sine x.
Great, excellent. Yes, thank you very much, Ahmed. So notice all of you that Ahmed guessed that here, my alpha here is 0. My alpha and beta is 1 here, my beta. Okay, this is my beta. And don't forget, please, for who didn't write the cheat sheet, you have to finish your cheat sheet today or tomorrow, because no new rules after tomorrow. And the cheat sheet must be written before the exam. You have to practice and you have to check the rules and your cheat sheet before the exam. The rule here, I have the y equal e to the alpha x cosine beta x. This is my first. And e to the alpha x sine beta x. So this is my y1, great Ahmed. And this is my y2, excellent. So now let me go to the second step. Second step, I remember. So second step, don't forget the steps, please. Second step is to find YP. For me, I remember the annihilator technique. Unfortunately, I can't use the annihilator technique because the sec is a fraction 1 over cosine. I remember that reduction of order method can help. So let me, I'm not going to solve the using the reduction of order, but I'm going to write the steps to let you remember how to do it using the reduction. But I'm not going to do that. I need to solve the variation of parameter, but let me write some steps about the reduction of order. Can anyone help the steps for reduction of order? Anyone, if you remember the steps of reduction of order? By the way, the reduction of order can solve this problem and you will receive full mark. But I'm not going to do that. I need to use the reduction of the variation of parameter. My question now, can anyone remember the steps of the reduction of order? It's very easy. No one remember? Yes? Speak please. Yes, David.
دكتور مش المفروض يكون معانا y1 عشان نستخدمه؟
This y1 here. And not only y1, also you have y2. Do you remember that y1 must be what? Do you remember y1 must be what?
Solution for the
Solution for the homogeneous. And here I solved the homogeneous. And not only y1, I also have y2. So I can use any one of them. So the step is what? If you have this y1.
integral e power negative integration
Yeah, I understand. So you will find, unfortunately, David, you will find y2. Am I right? But here is the y2. So no need to find y2 because I give you y. So you found it now. The solution of the homogeneous. y2, it is the solution for the homogeneous equation. Now you found y1 and you found y2. So no need to use this rule. So what should I do now?
You say that y prime equals omega?
No. This one is the third step maybe. Ahmed Atif, do you remember the step now? No
Y equals u y1?
Yes, y equal u y1. This is the first step. After finding y1, the first step to solve a reduction of order method is to write this substitution. Please try to use your cheat sheet during the lecture. And by the way, in the coming week, it's very important to write your cheat sheet from the first lecture in the coming week, okay? And you have to use your cheat sheet during the lectures. So to solve using reduction of order, you need to use this substitution. Where is y1? This is y1. And if you don't need to use this y1, you can use this y2. But look what I'm going to advise now. If you have two solutions for the homogeneous equation, like now, for the homogeneous equation, you have y1 and y2. I advise you to use the variation of parameter, not the reduction of order. So now I'm going to use the variation of parameters to find yp. Do you remember from your cheat sheet the rule of yp using the variation of parameter? Anyone if you wrote it? It is u1 y1 plus u2 y2. Okay? This rule must be written in your cheat sheet. Where is y1? It's given from the homogeneous solution. Where is y2? Is given from the solution of the homogeneous. What about of u1 and u2? So now my aim is to find u1 and u2. I don't know those two unknowns functions. How to find them? Also from my cheat sheet, I have to solve the following algebraic system. From my cheat sheet, I need to solve u1 prime, y1 prime. Sorry, it isn't a prime here. I'm so sorry. It's difficult to use here the eraser. Back my pen. So y1 plus u2 prime y2 equals 0. And the second equation, u prime 1 y1 prime plus u2 prime y2 prime equal fx. Okay? Don't forget that this is your rule, and this system, your rule for the variation of parameters. Let me write this system depending on my functions. So u1 prime times y1. Where is my 1? It is cosine x plus u2 prime, which I don't know, times y2, which is now my sine x equals 0. In the second equation, u1 prime times derivative of my 1, it is negative sine, plus u2 prime, derivative of sine, it is cosine x equal my fx. Where is my fx? Where is my fx?
Sec x.
Sec x. Sec x, you are right, sec x. Okay, now to solve this system, algebraic system, and I'm going to find u1 prime and u2 prime, I have to find the value of the Wronskian determinant w. So here the w equal, let me, yes, using the clue, the w, it is given to be the coefficients of u prime 1 and u prime 2. So it is cosine x my y1, sine x my y2, their derivatives negative sine x, cosine x. To find this determinant, it's very easy to do cross product. This by this, which is cosine squared x, minus this by that, so you have minus and your minus, so plus sine squared equal 1. And this one isn't 0 at all. I remember that. Now let me find W1. How to find W1? Do you remember? Anyone of you remember how to find W1?
Split the first column y0
Yes.
and s6.
Yes, replace the first column here by your right-hand side. So 0 and sec x. Sec x, where is the c? So here 0, sec x, and leave the second column, sine x, cosine x, equal. This by this, it is 0, minus this by that, which is sine times sec. Sine x times sec x. I found W1. Now let me find W2 here. W2 equal. I remember to find the W2, I'm going to replace the second column from W by my right-hand side. So I have here cosine x, the same column, first column, sorry. And the second column, I'm going to replace it with my right-hand side. So 0 and sec x. So here, just 1 minute, let me write the steps for solving this system. So this is the first step. Second step is to find those three W's, W, W1, W2. Now this answer, it will be this by this. So it is cosine x times sec x minus 0. Now cosine times sec. Cosine times sec, it is what?
1.
1. Because the sec, it is 1 over cosine. So it's 1. And by the way, also, sine times sec, it is negative sine over cosine. Now, after finding those three determinants, I'm going to find the u1 prime and u2 prime. So here, let me go back to the yellow. U prime 1 equal W1 over W, and U2 prime equal W2 over W. This is the third step. third step of the algebraic system equal the W1, I think it is negative sine x over cosine x, all of them divided 1. And the W2, it is 1. I forget. It is 1, yes. 1 over 1. Okay. So this, it is negative sine over cosine, which is tangent, you are right, over cosine x. And this is only 1. From this, I can say that u1 equal the integral of negative sine x over cosine x dx. And from this, I can say that my u2 without prime equal integral of 1 dx. Did you get the idea? So here the derivatives and here the integral. Can anyone of you remember the integral of negative sine over cosine? I remember this, it is x. Negative sine over cosine.
Len cosine.
Negative what?
Len cosine.
Len cosine, great. It is len absolute value of cosine x. Now I found u1 and u2. Let me go back. So your u1 and u2 must be substitute here. So yp in my second step, it is u1, which is len cosine x times your y1, what is it? Is cosine x plus u2, which is x times y2, which is sine x. This is my yb. Now third step, notice here, step number 1 in circle, step number 2 in circle, but here in square, in square, in square. Here, go back to circle. My y, the general solution of given differential equation is given to be yb, which I found here, plus yc, which I found in the first step. Here the yc, here the yc, and here the yp. Add them together, so you finished. So here, no need to write them. Len cosine x times cosine x plus x sine x, x sine x, plus my yc c1 cosine x, plus c2 sine x. This is the general solution of the given non-homogeneous differential equation. Any question? If no questions, let us solve a new one, a new example. Please write your names now. Write your names. And let us solve the second example. For me, when I have similar to this problem, notice, I can't solve it using the annihilator technique because my right-hand side is a fraction. So I can't use the annihilator technique. Let us together try to solve it using the variation of parameters, okay? And by the way, this problem can be solved using the reduction of order. Maybe I will give you a hint how to use the reduction, but I'm going to solve it using the variation of parameters. So now this equation is non-homogeneous, and I remember the first step to solve the non-homogeneous. So first step is to solve the homogeneous equation. So y double prime minus 2y prime plus y equal 0. And I'm sorry, I need now, I need Basil. Basil.
Yes, doctor.
Yes, could you please help Basil how to solve this equation?
Okay, so we're gonna start at m squared.
So because your coefficients are constant, so you can use the auxiliary technique. Great, m squared, continue.
Minus 2m
Minus 2m
plus 1.
equals 0. How to
Equals
solve
0.
this algebraic equation, Basil?
I don't have a calculator, but
Yes.
I guess it's like m minus 1 all to the power of 2.
Yes, great. M minus 2 all squared. So it's an identity equals 0. So your m?
It's 1.
My m is 1.
And debated.
Repeated.
M equals 1
Great. So you have to write here 2 times. It's repeated 2 times. Okay. So the complementary solution, which is the linear combination between 2 solutions for this equation, it's given to be yc equal, yes.
e to the power of x, c1 e to the power of x,
C1 e to the power x, okay, plus?
plus c2 x e to the power of x.
Great. So you multiplied by x here because your m is repeated. Yes, thank you very much, Basil. So now notice that Basil said, I have this y1, this is my y1 now, and this is my y2. Those are the solutions of the homogeneous equation. Second step, if you remember, so second step here is to find yp. How to find yp using the variation of parameters said that my yp from my cheat sheet is given to be u1 y1. I found y1 here, but u1 I'm going to find plus u2 I don't know times y2 I found it here. So my aim now is to determine the value of the unknowns function u1 and u2. The reduction of order method now, so leave this and let us speak if the student need to use the variation of parameter. So reduction of order. So here the hint for reduction of order. Reduction of order. Actually, the reduction of order can solve this equation. Why? Because I have first solution. So you can write this substitution, which you need to write near the reduction of order method, that y equal u times y1. Where is my y1? You can choose this or you can choose this. You are free. Okay? Because y1, it's a solution for the homogeneous equation. I'm not going to use this. Professor, if I use it in my exam, you will receive full mark. But my advice now, if you have two solutions for the complementary, it's a homogeneous. So you have two solutions for the homogeneous. So the variation of parameter method will save my time. So maybe if I use the reduction of order and use this substitution, maybe you need 10 minutes. But if you use the variation of parameters, you need 8 minutes. So you will save 2 minutes. Okay? That when you have two solutions. But if you have only one solution like this and you don't have this, at that time, you must use this and the variation can't help. Okay? Now, let us continue. Here, what I'm going to do, how to find U1 and U2. Do you remember? In my cheat sheet, I have to solve the following system. Let me use another color to solve this system. 1 minute. So I'm going to solve the system. U1 prime Y1 plus U2 prime Y2 equals 0. And U prime 1, Y prime 1 plus U2 prime y2 prime equal fx. The system is given to be u prime 1 times my y1, it is e to the x, plus u2 prime, a known function, times my y2, it is x e to the x, equals 0. Now, u1 prime, I'm sorry, times derivative of my y1, which is e to the x, plus u2 prime, which I don't know, times the derivative of this function equal my fx. Where is my fx? Where is my fx? It is e to the x divided 1 plus x. And the derivative of my function, it is e to the x plus x e to the x. Okay? Now, to solve this system, I'm going to follow this. So this is the system. I'm going to solve this system using the Grammar's rule. So I'm going to find the W. Don't forget that the W is given to be your functions y1 and y2. So it is e to the x and x e to the x. Second row is their derivatives. So it is e to the x here. And here it is e to the x plus x e to the x. Now I'm going to find the value of this determinant. Let me write it here. Okay. it is this by this. So I have e to the x times e to the x. It is e to the 2x plus x e to the 2x minus this product, which is x e to the 2x. Now this term similar to this, cancel them out. So it is e to the 2x. And I think all of you know that e to the 2x can't be 0 at all. So I found here the w. Now I'm going to find w1. Yes, I need one to help now. How to find w1? Let me ask Muhammad Yasser.
Yes, doctor.
How to find w1? Do you remember?
هنحط ال values في الناحية الشمال اللي هي
Yes.
ال right hand side values في الناحية الشمال.
Yeah, instead of the first column, you are right. So 0,
And e to the power of x over 1
1 plus x. And what about second column?
هتبقى اللي هي x e to the power of x.
The same. Okay, great. And here x plus x e to the x. How to find the value of this determinant? This by this, which is 0, minus this by that. The answer, it will be what? So here x times e to the x times e to the x, it will be 2 e to the 2x, okay? Am I right? Here divided 1 plus x squared. Second step is to find W2. And also, as Muhammad said, leave the first column, and change the second column to be your right-hand side, 0 e to the x divided by 1 plus x squared. To find its value, this by this, so it will be e to the 2x divided 1 plus x squared, minus this by that, which is 0. Okay? Now, third step is to write the rule of u prime 1 equal w1 over w, which is given to be. My w1, it is negative x e to the 2x divided by 1 plus x squared. All of them divided by w e to the 2x. How to simplify this? Muhammad, could you please help how to simplify? Muhammad Yasser, how to simplify this?
هي ال 1 plus x square وال e to the power of x هما في نفس الناحية، بس هنعمل ال e to the power of x اللي في النومينيتور ونشيل ال e to the power of x اللي تحت خالص.
Yeah, so this one, it will be a new denominator here. And I can cancel out with this. Can I do that?
Yes.
So it is negative x over 1 plus x squared. Now, I have to find u1 to be integral of this. Can anyone help to find this integral?
Negative ln 1 plus x squared.
Negative ln.
Negative half.
Negative half. So always, for those who find some difficulties to find the integrals, you have a fraction. You have to look if the numerator here is the derivative of your denominator or very close. The derivative of my denominator, it is 2x. So I need 2. So I'm going to multiply by 2 and divide by 2. And don't forget to take the negative out. So it's negative half ln of the absolute value x, 1 plus x squared. So x squared plus 1. This is my u1. Let me go to a new slide to find u2. u2 prime equal w2 divided w, which is, if you remember that your w2, it was, my w2, it was e to the 2x divided this term, e to the 2x divided 1 plus x squared, all divided e to the 2x. Simplify it, you will cancel out e to the 2x with e to the 2x, so you have 1 over 1 plus x squared. So your u2, it's the integral of this function. Do you remember the rule of this integration?
هو tan تقريبا.
Yes, it's tan, arctan. Am I right?
arc tan.
This is my U2. So the YP, let me go back to the yellow. YP, it is U1 times Y1. U1, it's negative half ln 1 plus x squared times my Y1, it is e to the x plus my U2, it is arctan x times my Y2, it is x e to the x. This is my YB. Third step, to give the general solution of the given non-homogeneous to be YP, which you found in second step, plus YC, which you found in the first step. So do you have any question here? Any question? Let me solve another problem. Here, problem number 3. But let me do first problem number 4. And if we have time, I'm going back to number 3. And if we didn't have time to do number 3, please try to do it in details and send me your solution in WhatsApp. Now, problem number 4. Maybe it's more complicated. Let me check. I don't know. So I have to solve this differential equation. And actually, he asked me to use the variation of parameters. Take care that in the exam, I'm not going to write the method. I will write, please solve the following differential equation. And you have to decide that I need to use variation of parameter, reduction of order, annihilator. I'm not sure what you have to do at that time. Now, let me read the question. I have to solve the following differential equation. So I need to solve this differential equation. I have to find the solution of this differential, the general solution. Notice first of all that those coefficients aren't constant. And also your right-hand side is complicated function. So you have two difficulties. The first one, that your coefficients aren't constant and your right-hand side isn't simple function. You can't annihilate it. You can't annihilate it. So now, notice he give me Y1 and Y2. Those are independent solutions for corresponding homogeneous. It's great. So he give me two independent solutions for the homogeneous equation. Let me go to black slide and discuss the steps together. So here, the differential equation. For me, the given differential equation is non-homogeneous. So to solve it, I think first step is to find YC. How to find YC? By solving the homogeneous equation. But now I can't solve the homogeneous equation because non-constant coefficients. Can anyone help how to find YC? Don't forget that he gave you the Y1 and Y2 as the solutions for the homogeneous equation. So the YC, it will be what?
C1 Y1 plus C2 Y2.
Great, C1 Y1 plus C2 Y2. Please, I don't need only David to answer the questions. Please share with me. That will help you to understand more. So equal C1, my Y1, it is cosine ln x plus C2 sine ln x. This is my YP. Don't forget your Y1 and your Y2 is where. Now, second step is to find YB. Don't forget that you can use the reduction of order by using reduction of order y equal u times y1 or y2. And you have here y1 and you have y2, so you can use this. But this method need 10 minutes. In this example, please, in this example need 10 minutes. And I advise you always, if you have two solutions For the homogeneous equation, please use the variation of parameter. But if you have only one similar to this, and you don't have this, so use the reduction of order. So some students will write now this hint. If I have only one solution for the homogeneous, use reduction. If I have two solutions, use variation. Okay? I said it in this recorded video, so you can listen to the recorded video again if you forget. So now my YB using the variation of parameters is given to be YB equal U1 times Y1 plus U2 times Y2. Where is my Y1 and Y2? The given functions. Where is my U1 and U2? Those functions, I need to find them. How to find them? By writing this system. U1 prime times Y1 plus U2 prime times Y2 equals 0. And also U1 prime Y1 prime plus U2 prime times U2 prime Y2 prime equal Fx. Now I need some help to write this system. U1 I don't know. Y1 it is given to be cosine ln x plus U2 it is prime here. U2 prime times my Y2 it is sine ln x. Now here second equation. Can anyone help to find the derivative of cosine ln?
Doctor, you forgot to add the ln in the sign.
I am sorry. Ln. So now, derivative of cosine ln.
Negative sine ln
Negative
over x.
sine.
Yes, negative sine ln x all over x, the derivative of ln x, plus, also here the same, u prime 2 cosine ln x over x equal, help please, where is my fx?
Sec ln x.
Sec ln x, sec ln x. Other students, what do you think? Is it right? Sec ln x
Over x squared.
all divided over x squared, divided by x squared, because we agreed to use the variation of parameter methods. You need the coefficients of y double prime to be 1. So here, let me write in blue. Give me 1 minute. You need to divide your equation by x squared. So you have y double prime plus 1 over x by prime plus 1 over x squared y equal seclin x divided by x squared. Okay, is it clear now? Let me go back
Yes.
to the yellow now, and I'm going to find the Wronskian determinants. Yes, W equal, I have cosine ln x, sine ln x, and here negative sine ln x all over x, and cosine ln x over x. Now it's very easy to multiply this by this, so it has cosine squared ln x all divided x minus from my mind, and this by that I have minus, so it is plus sine squared ln x divided x. Can anyone help?
It will be 1 over x.
1 over x, great, because the up is cosine squared plus sine squared, not equal 0. Now, let me find W1. I know To find W1, I'm going to replace my first column by my right-hand side, 0, sec ln x, all divided x squared. The same second column, sine ln x, and here cosine ln x divided by x. This by that is 0 minus this by that. So it is sine ln x times sec ln x all divided x. Can I simplify this? Or leave it? I'm not sure. No problem. Now from this, I'm going to write here. From this, I can say that u1 prime equal w1 over w equal negative sine leg sec ln over x all divided 1 over x. So u prime equal what?
دكتور مش هي it's supposed to be x squared يعني sin ln x sec ln x over x squared.
You asking me about this?
Oh yes.
Oh,
You
yes.
are right. It must be here x squared. Am I right here? No,
لا
here.
يعني
I'm so
sin
sorry.
x squared.
You are right. You are right. Great. So what should I do now? So here x squared. Thank you, Abdurrahman. How to simplify if I have two fractions?
لا دكتور الاكس اللي فوق سكوير مش اللي تحت.
I'm sorry. 1 minute. So here. I'm so sorry. Great. So how to simplify this fraction now?
الاكس هتكنسل مع واحدة من الاكس سكوير.
You are right. Great, Omar. So you one prime, it is given to be negative sine ln x times sec ln x all over x. I'm going to new slide to write it. So u prime equal. Can I write it as, what about of sine times sec? It is what?
Tan.
Ln.
Tan ln x.
Tan. Yes, you are right. Tan. So I have negative. Let me write 1 over x sine x over cosine x. It is ln x. I'm so sorry. And here cosine ln x. Am I right here? Let me check. Instead of sine times sec, I wrote over cosine x, and I left 1 over x. Now I need to integrate this. So u1 equal integral negative 1 over x times sine ln x divided cosine ln x. Any help to integrate this complicated function? What do you think?
Then cosine ln x.
Ln cosine ln x? No, I don't understand. From where you get this answer? Your answer is
the
right.
derivative of
Yeah,
sine ln x equals negative sine ln x over x.
you are right. For me, I can't do that in my mind. How to solve this? To integrate this in function?
We can take cosine ln x as u.
No,
and
no. Cosine
Gotcha.
ln x. Let me check. Actually, maybe yes. I can.
And take ln x as u.
Yeah, and also I can take ln x equal u. So I will use substitution. First substitution, cosine ln equal new variable, or the ln is a new variable. You are right. So I'm going to choose the ln. Let ln x maybe v. So dx over x, it is dv. dx over this x, it's my dv. So my integral, it will be, let me go back to the yellow. So I have the blue are du. So I have du here, and integral negative sine u over cosine u. It is t, it is v, not u. It is v. It is v, no u. What do you think about this integral? It is tan, by the way. It is what?
Ln cosine v.
Ln cosine v. Ln cosine v. Go back to your v. So equal ln cosine. My v, it is ln x, as David said. This is your u1. This is your u1. This is my u1. Let me find u2. Unfortunately, to find u2, I need to find the w2. I didn't find w2. To find w2, I'm going to use the same column, but I'm going to replace the second column. So it will be cosine and negative sine ln. So here w2 equal, it is cosine ln x, cosine ln x, and I'm so sorry, and negative sine ln x, negative sine ln x, all divided by x. And here I'm going to use the second, the right hand side to be 0 sec ln x, 0 sec ln x over x squared equal. This by this will give me cosine ln x times sec ln x all over x squared minus 0 equal. What do you think about cosine times sec?
1.
1. So I have 1 over x squared. No 0 here. 1 over x squared. After finding w2, I'm going to find u2 prime equal w2 over w, which is 1 over x squared, all divided. Where is my w? Where is my w? It's 1 over x. 1 over x. To simplify this, I will get 1 over x squared, 1 over x. Simplify, please. You have to share with me.
It will equal 1 over x.
1 over x. So your u2, which is the integral 1 over x, it is dx, it is ln x. This is my u2. So yp, it is my u1, which is ln cosine ln x, times y1, which is cosine ln x, given cosine ln x, plus your u2, which is ln x, times y2, which is sine ln x. This is my yp. After finding yp, the third step is to write the general solution of the given non-homogeneous to be yp plus yc. And we found yc in the first step. What do you think about this problem?
But doctor,
Yes.
what if you didn't give us the y1 and the y2? We will have
Yes,
to.
great question. So now Mahmoud asking me the following question. Doctor, I have this differential equation in my exam. Okay. And continue, Mahmoud. Continue.
And the y1 and y2 are not given.
And I don't have y1 and I don't have y2. Okay. So you don't have y1 and you don't have y2. For me, depending on all what we studied, I can't solve this equation unless if I guess one solution for the particular. So maybe if the student is clever or the professor also is clever, can guess y1 and y2. But I'm not going to ask you to guess them in the exam. So in your exam, you can't or know at all this differential equation with no y1 and no y2 at all. Okay, Mahmoud?
Okay, thank you, Doc.
But maybe when we will use the Laplace transform next week, we can deal with this equation. And also, by the way, maybe you have this differential equation with only y2. So you can do this equation. In your exam, we can do this equation. How to do that? Such that the y2 is one solution for the homogeneous associated equation. Can anyone help if I have only y2 or only y1, not both of them? How to solve the equation at that time?
We use reduction.
Order. And do you remember the substitution for the reduction of order method? It is what?
Y equals uy1.
Y equal u times y1. Y1 is the given solution. Don't care if it is has a name y2, y3. It's the solution for the homogeneous. Is it clear? We have 6 minutes maybe. Let me start solving the last one, which I asked you to do and send it to me on WhatsApp. We can discuss together, but we don't have time to finish all the steps. So I'm going to give you only the hints to solve it. And please, if you have time, try to do it. And by the way, I uploaded the materials for exam number 2. Please start preparing for exam number 2 and take care. Usually, exam 2 is harder than exam 1. Okay? So you have to practice and to solve the problems by hand. And we don't need the materials or the lectures which we cover for section number 1, only the linear first order differential equation, because we used this method to solve the reduction of order technique. Now, this equation for me, I'm going to write the steps, but I'm not going to write everything in details. Let me write here up. First step is to solve the homogeneous equation. So y double prime minus 2y prime plus 1 equals 0. How to solve this equation? Just 1 minute. I need to ask Ziad Salim. Could you please help Ziad? Do you remember how to solve this?
No يا دكتور.
No. So
we can الأول خلاص دي m squared minus 2m plus
yes.
1.
Yes, great. Great, equals 0. How to solve this algebraic equation?
We'll try to put it into brackets, but will it work or not?
Yes.
mm.
Yes, great. And the product is, no, your product is 1. Could you please give me 2 numbers? Their product is 1 and their summation is 2.
1 and 1.
1 and 1. 1 and 1. But now the summation was negative and the product is plus.
Minus and plus.
No, it must
minus
be
and
the
minus,
same.
sorry.
Yes. So your first m is 1 and your second m is 1.
M is 1 برضه.
Do you remember now the complementary solution is what? If you have the same m and repeated it.
First one will be the normal C1.
So C1 e to the x and second one?
And then C2 x e power x.
Great, Ziad. Great, excellent. Now, second step, thank you, Ziad. Second step, I'm going to write it here, is to find yp. Because you have 2 solutions for the homogeneous here, okay? So you can use the variation of parameters and let your yp equal u1 y1 plus u2 y2. How to find u1 and u2? From my cheat sheet, I have to solve the following system. u1 prime y1 plus u2 prime times y2 equals 0. And second equation in which I'm going to use to find the u1 and u2, u1 prime y1 prime plus u2 prime y2 prime equal my fx. Where is y1, y prime 1, y2, y2 prime? Is from here. This is your y1, and this is your y2. How to find those? I'm going to find u1 dash and u2 dash, then integrate them to find yp, then add together. Where is your fx? It is this function. I'm not going to continue solving it. Please try to do and send me your solution on WhatsApp. And by the way, in the exam, maybe I'm going to clean everything here. I'm going to clear everything. So now, maybe in the exam, you will find the same problem. Maybe, I'm not sure, but with no variation of parameter. So I will ask you, solve the differential equation. Okay, and you have to use the variation of parameters. So I'm not going to ask you use the variation. You have to know that I need the variation. Okay, so do you have any question now? Anyone, if you have a question?
Doctor, is there any updates about the time
exam?
of
Yes,
the
it will
exam?
be 8:30 a.m. the same time, and the final also at the same time, at the same room, in the same room. Okay.
يعني ما فيش أمل إننا
No.
نأجل الوقت؟
No.
Okay.
I'm sorry. And by the way, the final it's scheduled before the semester, so we can't. And the exam 2 and exam 1, we agreed, me and the department, to be at this time. I'm sorry that because some of you, it's difficult, but I think it's better. So we'll do the exam and go and sleep as you need. Okay, other students, do you have any question?
Doctor, will I be able to get an online alternative